Okay, so in this lesson, we're going to talk about graphing non-linear graphs, so graphs that are not lines. For this lesson, though, we're going to look at y equal x squared, or you can also write it as f of x equal x squared. So this right here is in function notation, so this is function notation. And you're going to learn more about function notation in the next lesson, but function notation. And basically, f of x means the same thing as y. So notice that you can write this as y equal x squared or f of x equal x squared. All right, so you can learn more about this idea and what you can do with function notation in another lesson. Okay, now y equal x squared or f of x equal x squared, the graph is a parabola. It's not a line. So remember, we're looking at non-linear graphs, so graphs that are not lines. So when we graph this, you're going to see that the graph is called a parabola. All right, parabola. This is called a quadratic function. Quadratic function. In the previous lessons, you learned how to graph linear functions. So graphs that were lines, so linear functions. Here you're looking at quadratic functions. So what makes a quadratic function is that the largest exponent of the variable is 2. So this is x squared, the exponent's at 2, so you end up with a quadratic function. And the graph is going to be a parabola. So the graph is a parabola. And you're going to see what a parabola looks like as we graph this function. All right, so let's talk about graphing y equal x squared. The best way for right now to graph y equal x squared is to use a t-table. So let's use a t-table. And when I use a t-table, I'm going to substitute numbers for x, and then I'm going to find the y value. Because y is by itself, since y is by itself, it's easier to pick numbers for x and substitute here, and then I square it, and that's my y value. All right, so since y is by itself, choose values for x. So for example, if x is 0, I get y equal 0 squared. Well, 0 squared, 0 times 0 is 0. So I get the point 0, 0. Now, also remember in a previous lesson, you also learned that these are solutions. So whenever you're plotting these points, whenever you're plotting points or whenever you're determining what points makes this equation true, those are solutions. So the solution to this equation, one of them, there's an infinite number, one of them is the point 0, 0. So when x is 0, I get 0 squared. When y is 0, 0 equals 0, that's a true statement. So you're finding solutions. So when you graph, whether it be lines or nonlinear lines, nonlinear graphs, you're plotting solutions. All right, so let's say x is 1. When x is 1, I get y equals 1 squared. 1 times 1 is 1. If x is negative 1, so I can use negative values for x as well. If x is negative 1, now be careful because I'm squaring x, so x is negative 1. So remember, there is a difference between this versus this. So recall in the previous course that this right here says I'm squaring a negative 1. So this right here means negative 1 times negative 1, which is a positive 1. When there's no parentheses there, mathematically, the only thing you're squaring is this 1 right here. That's the only thing you're squaring, is this 1. So this means that whatever 1 squared is, which is 1, it's going to be negative. So I get a negative, and then 1 times 1, which is a negative 1. So there's a difference between those two. So remember in a previous course, you learned about when you have a value raised to a power, sometimes the base, remember this is called the base, Sometimes the base was in parentheses, sometimes it was not. So there's a difference between that. So when you do this one, you're squaring a -1, so you have to put in parentheses. So that's -1 squared, and we just saw that -1 squared is a +1. If x is 2, I get y equals 2 squared. And you could put this in parentheses. I'm not, because the base here is positive, so I'm going to just leave it as it is. So I get 2 times 2, which is 4. If x is -2, now this time I am going to use parentheses, because if I don't, remember there is a difference between these two statements. Oops, I did not mean to put an equal sign. So there's a difference between these two statements. This right here, this -2 right here, make it a little bit better. -2 squared means -2 times -2, which is a +4, just like our discussion a while ago. Here, the only thing being squared is 2, so that means -2 times 2, which is a -4. So notice you don't get the same value. So when I substitute -2 in for x, I get y equals -2 in parentheses squared, which is 4. If x is 3, I get y equals, and again, I don't need to put parentheses there. I could if I want to. If I wanted to put parentheses there, I could. Does not matter. But regardless, it means 3 times 3, which is 9. If x is -3, I get y equals a -3 squared. Remember, you got to put that in parentheses, a -3, which is -3 times -3, which is a +9. All right, so notice you can keep on going with this. You have an infinite number of points that are on this graph. But I only need a few. You need more than 2, because remember, when graphing lines, you really needed 2 points. All you needed were 2 points, but we chose 3 just to make sure that all those points were collinear. But when graphing nonlinear graphs, you need to make sure you have enough points. You have enough points to be able to draw the graph. So when I plot these points, let's see what happens when I plot these points. So when I plot these points, I get I get 0, 0. I'm plotting the point 0, 0, which is here. And then 1, 1. So 1, 1 is here. And then -1, 1, which is here. And then 2, 4, which is here. -2, 4, which is this point here. 3, 9. So remember, you start at the origin, you go to the right 3, and you go up 9. So 3, 9 is here. And then we also had -3, 9. So -3, 9 is here. All right. Now notice this is not a line. Those points are not collinear. See, those points are not collinear. And they're an infinite number of points. I just found these points. All right. Now do the best you can with connecting these dots with a curve. So it's got to be a curve. Don't draw segments here. Those are curves. So it's got to be a curve. It's got to look just like this. And see how I'm doing it? I'm just kind of doing like a little shading in as much as I can, like this. All right, just like this. And then on this side, you do the same thing. Okay, it's got to be a curve. If it doesn't look like a curve, you erase it and redraw it. Make sure it goes through those points, just like this. All right, and so there's the graph of y equal x squared, or f of x equal x squared. That's what it looks like. That graph is called a parabola. This is a parabola. We use the word parabola. So that graph is a parabola. Parabola looks like this, like a U. Okay. All right. Now, a couple of things I just want to say about this, and I could help you. That information could help you in graphing versions of this. So what's going to happen at some point is that you're going to graph variations of y equal x squared. So basically, you're going to graph parabolas that have been shifted either to the left, right, or up, down. All right, so we're going to talk about that. So basically, what I'm talking about is this. So given this, we're going to now graph. Parabolas that have been shifted to the right, parabolas that have been shifted to the left, parabolas that have been shifted down, parabolas that have been shifted up. Okay, that's what we're going to talk about. Before we do that, though, let's talk about some terminology with respect to a parabola. Okay, so you see this low point as I go from left to right. My my y values. See, these are y. You have this point here contains an x and a y coordinate. But let's look at the y coordinates. My y coordinates are decreasing. My y coordinates are getting smaller and smaller and smaller. Because look, right here, this was a point. Right here, this was a point negative 3,9. And right here, this was a point negative 2, 4. So notice my y values are getting smaller. This point, the y value was 9. This point, the y value was 4. Over here, this point, the y value is 0. Right here. Remember, that's the origin. 0, 0 is the origin. Okay, but regardless, what I was saying was that as I go from left to right, my y values are decreasing, and then all of a sudden they're increasing. Okay, my y values are getting smaller and then larger. This point right here, the smallest point, the lowest point, I should say, the lowest point on the graph in this particular case, the lowest point, this is called the vertex. That's called the vertex. Now, it could have gone, see how my parabola is rising up? It could have, your parabola could have opened down instead. It opens up versus opens down. In that case, and we're going to look at situations like that as well, but in that case, it will look something like this, let's say. I'm just making it up. It will look something like this. So you probably open down. This right here, this point is still called the vertex. The vertex. So the vertex is either the lowest point on the parabola or it's the highest point on the parabola. But for right now, we're just going to graph parabolas that open up for right now. That's what we're going to focus on. So when we graph these parabolas that open up, the vertex is going to be the lowest point. Now what I want you to do is when graphing these parabolas, try to locate what the vertex is. Try to determine what the vertex is. Once you determine the vertex, then you're going to pick about, see how I did three points here? Pick 3 points to the two or three, does not matter. 2 or 3 to the right, 2 or 3 to the left of your vertex, and then you're done. You just plot the points, you graph it, and you're done. Okay? All right, so that's the vertex. Now, the other thing I want you to notice is that if you look at this parabola right here, y equals x squared, if you look at y equals x squared, see this y-axis? This y-axis goes through the vertex. See this y-axis, here's the vertex, it goes through the vertex. And this parabola is symmetrical about the y-axis. So in other words, if you look at this distance right here, the distance from the y-axis to this point, which is 2 units, 1, 2, is the same distance here, 1, 2. This distance here from the y-axis, that's 3 units, 1, 2, 3. From here, it's 1, 2, 3. So if I were to reflect this part, if I were to fold it, I would get this part here. All right, so this graph is symmetrical about the y-axis. So when we graph these parabolas, there's going to be symmetry. So when graphing this, use symmetry to help you graph this. So just make sure it looks symmetrical. So if this is your vertex, you think of this imaginary line going through the vertex and make sure it's symmetrical. Make sure it's symmetrical. Okay, so now let's graph this one. So we're going to graph variations of this quadratic function. So let's look at this one now. So let's suppose you want to graph y equal, I'm going to use f of x. So let's suppose you want to graph f of x equal is number 2, f of x equal x squared plus 4. X squared plus 4. All right, now I'm going to use a t-table. And I'm going to, again, let x be 0. So when x is 0, I get, and remember, f of x means the same thing as y. So I'm going to get y equal 0 squared plus 4. And order of operation, remember, you square before you add. You do the exponents before you add. Order of operations. I'm using order of operations. And so I get 0 squared is 0. 0 plus 4 is 4. So at the point 0, 4. If x is 1, again, I'm using the same, for these right here, I'm using the same values of x. So I'm going to go down and say 0, 1, negative 1, 2, negative 2, and so on. So when x is 1, I get y equal 1 squared plus 4. 1 squared is 1. 1 plus 4 is 5. So you have the point 1, 5. If x is negative 1, remember, since x is negative 1, you got to put that in parentheses. I get y equals negative 1 squared plus 4. Negative 1 squared, remember, is a positive 1. Negative 1 times a negative 1. 1 plus 4 is 5. If x is 2, I get y equal 2 squared plus 4. So 2 squared is 4. 4 plus 4 is 8. If x is negative 2, I get y equal negative 2 in parentheses squared plus 4. And negative 2 times a negative 2 is a positive 4. 4 plus 4 is 8. All right. And then if if you look at the grid that we're using, so notice I can go all the way up to a positive 19. So I'm going to go ahead and use a 3 here. So if x is 3, I get y equal 3 squared plus 4. 3 squared is 9. 9 plus 4 is 13. And if x is negative 3, I get y equal negative 3 squared plus 4. Negative 3 squared is 9. 9 plus 4 is 13 also. Now you'll notice that when x was 1 and negative 1, I got the same y value. When x is 2 and negative 2, I have the same y value. When x is 3 and negative 3, I have the same y value. That has to do with symmetry and where the vertex is. So you'll see this in the discussion in a while. So let's go ahead and plot those points. So when I plot those points, I'm going to get, I get 0, 4. So I get 0, 4, which is here. My other points are 1, 5, which is here. Negative 1, 5, which is here. 2, 8. So 2, 8, which is here. Negative 2, 8, which is here. 3, 13, which is, let's see, right here. And then negative 3, 13, which is here. All right, and so if I draw my graph, remember it's got to look like a parabola. So make sure this looks like a curve. If it doesn't look like a curve, it's not correct. It's got to look like a curve, just like this. Do the best you can, just like I'm drawing it. Do the best you can with drawing this. Same thing here. Make it look like a curve. And make it look symmetrical. Make it look symmetrical. So notice the vertex is still on the y-axis. You see this? It's on the y-axis, but it is not at the origin like this one was. See, this one's at the origin. Y equal x squared, that was at the origin. But it was on the y-axis. Here the vertex is no longer at the origin, it's actually moved up 0, 4. But it's still on the y-axis, and so notice the y-axis, think of the y-axis as the axis of symmetry. So if I were to fold this part about the y-axis, I will get that part. And remember, these distances have to be the same. See how this distance here is 3 units? And this distance here has to be 3 units as well. If this is 2 units, this has to be 2 units. If this is 1 unit, this has to be 1 unit. So use symmetry to help you. So this right here is the graph of f of x equal x squared plus 4. Now I want you to notice something. Let's talk about this idea about where the vertex was. So remember, f of x equal x squared was here. Remember this? That's where it was. So the blue, that blue here, the blue is f of x equal or y equal x squared. The red is the quadratic function y equal x squared plus 4. So what happens is that this blue graph is being shifted up 4 units. So let me show you. I'm trying to get the light out of the way. So this is where it was. You go up 1, 2, 3, 4. Okay? So again, notice that the blue is y equal x squared, and the red is y equal, oops, I didn't mean to do that. The red is y equal x squared plus 4. That was the red. So when I take this, the blue graph, and move it up 4 units, 1, 2, 3, 4, it overlaps. The blue and the red overlap. Okay, so it's supposed to overlap. All right, now let's talk about the vertex. So notice that the vertex for y equal x squared is the origin. All right, so it's important for you to remember that. The vertex, when you're just graphing x squared, that's the origin. For x squared plus 4, let's think about how to find that vertex. For x squared plus 4, what I did was I took x squared, and I moved it up 4 units. Okay, so see this x squared plus 4? So you take the x squared, so you take the blue graph, and you move it up 4 units. 1, 2, 3, 4. So the vertex now becomes 0, 4. So for this one, keep in mind that the vertex here, this is the vertex, is 0, 4. So once you find the vertex, then really all you need to do is just find 2 or 3 points to the left, 2 or 3 points to the right, and then 2 or 3 points to the left of the vertex. But you got to determine how to find the vertex. All right, so remember, if it's just x squared, the vertex is 0, 0. What that plus 4 does is it moves it up 4 units, so now it becomes 0, 4. So what's here, move it up 4 units, becomes 0, 4. All right, so let's talk about how to find the vertex. So if you have this, f of x equal x squared minus 3, what do you think the vertex would be? Let's talk about the vertex. So if all you had was y equal x squared, then you know the vertex. So the vertex would be 0, 0. But that subtract 3 means that you're bringing the vertex down 3 units. You're bringing the vertex down 3 units, meaning this. So the vertex was at the origin. It's moved down 3 units, now the vertex is here, and that's the point 0, negative 3. 0, negative 3. So the vertex of this would be 0, negative 3. If we had y equal x squared minus 8, then the vertex, remember, if it's just x squared, if this subtract 8 wasn't there, we'd have y equal x squared. You know the vertex is the origin. But you're graphing y equal x squared minus 8, so now you're going to bring the vertex down 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. So the vertex is now 0, negative 8. All right. So for the remainder of the few problems we're about to do with x squared, we can look at the vertex. Okay, so let's look at this one. Let's graph number 3. Let's graph f of x equal x squared minus 5. X squared minus 5. All right, so x squared minus 5. So remember, what you're doing is you're taking the graph of x squared and then moving it down 5 units. So you're taking the graph of x squared. So let's kind of see what that looks like. So here's the graph of x squared, remember? It's the graph of x squared. And they're going to move it down 5 units. So 1, 2, 3, 4, 5. So that will be the graph of y equal x squared minus 5. So when we graph it, you'll see that that's what it's going to look like. All right, now, what I want you to do is try to determine the vertex first. So the vertex for the x squared minus 5 is 0, negative 5. That's a vertex. So it was, for x squared was at the origin. I move it down 5 units, so I get this point here for the vertex. It'll be 0, negative 5. So think of it that way. Once you find the vertex, and you plot it, once you find the vertex and you plot that point, which is, let's see, was 0, negative 5? Yep, 0, negative 5. Once you find that vertex and you plot that point, then all you do is plot a few points to the right and a few points to the left of that vertex. Okay? So we can say something like let x be 1, let x be 2, let x be 3. Then you could do negative 1, negative 2, negative 3. That's what I would do. All right, so let's do that. So we now know the vertex. So I found the vertex. In other words, if I do a t-table, I'm going to get when x is 0, that was a vertex. When x is 0, I got y to be negative 5. That kind of makes sense because look, when x is 0, I get y equal 0 squared minus 5. 0 squared is 0. 0 minus 5 is a negative 5. When x is 1, I get y equal 1 squared minus 5. 1 squared is 1. 1 minus 5 is a negative 4. If x is negative 1, I get y equal a negative 1 squared minus 5. That's minus 5. 1 squared is 1. 1 minus 5 is a negative 4. Remember the idea of symmetry. If x is 2, I get y equal 2 squared minus 5. 2 squared is 4. 4 minus 5 is a negative 1. When x is negative 2, I get y equal negative 2 squared minus 5. Negative 2 squared is 4. Negative 2 times negative 2 is 4. 4 minus 5 is a negative 1. All right? So you need to plot at least 2 points to the right of the vertex, 2 points to the left to get an okay parabola to graph. Okay, so when I do that, when I graph those points, notice what's going to happen. When I plot those points, I get, so here's 0, negative 5. I get 1, negative 4, which is here. And I get negative 1, negative 4, which is here. I get 2, negative 1, which is here. And I get negative 2, negative 1, which is here. And so basically I just draw my parabola, just like this. Do the best you can. Look something like this. Make it look like a curve. Don't make it look like a parabola. Gotta look like a parabola. And notice the vertex is still on the y-axis. So use the y-axis to help you with symmetry. Make it look symmetrical. So there's the graph, y equal x squared minus 5. So if I take the blue graph, I'm going to show you what's going to happen. So if I take that blue graph, the one that we said was x squared right here, So this right here, the blue graph is y equal x squared. Notice to get the red graph, x squared minus 5, I go down 5. 1, 2, 3, 4, 5, and notice they overlap. Okay? All right. Let's look at this one. Suppose we had this. Suppose we had f of x equal x squared, let's say minus 7. X squared minus 7. Let's suppose we had that. It helps if you find the vertex. So the vertex, and kind of do this, kind of think of x squared first. What's the vertex of x squared? Well, the vertex of x squared is 0, 0. It's the origin. But I'm not graphing x squared. I'm graphing x squared minus 7. So that means I'm going to move every point down 7 units. So instead of the vertex being at the origin, it's now going to be right here, which is the point 0, negative 7. All right, so the vertex is 0, negative 7. And it kind of makes sense because if I do that t-table, when x is 0, and this is going to be the vertex, when x is 0, I get the point y equal 0 squared minus 7. 0 squared is 0. 0 minus 7 is a negative 7, which is what we said it was. Now, once you find the vertex, pick 2 points to the right, 2 points to the left, and then you're done. So I would just, since the vertex is the x value is 0, then just pick x1, x2, x3, whatever you want. Just make sure it's within this grid. Make sure the point you get, you can plot it. So if x is, let's say, 2, if x is 2, I get y equal 2 squared minus 7. 2 squared is 4. 4 minus 7 is a negative 3. If x is negative 2, I get y equal a negative 2 squared minus 7. A negative 2 squared is 4. 4 minus 7 is a negative 3. If x, let's say, is 4, I get y equal 4 squared minus 7. So that's 16 minus 7, which is 9. If x is negative 4, let's say, I get y equal negative 4 squared minus 7. Negative 4 squared is 16. 16 minus 7 is 9. All right, so I applied 2 points to the right and 2 points to the left of the vertex. So then when I plot the remaining points, notice what I get. I get 2, negative 3, which is here. And remember, you could have chose 1 and 2. It does not matter. I just chose these points that I'm plotting. Negative 2, negative 3 is right here. Remember, use the idea of symmetry. 2 units to the right, 2 units to the left. If x is 4, I get 4, 9, remember. So 4, 9 is here. And then negative 4, 9 is here. And then all you do is do the best you can with drawing something that looks like a parabola. It's got to look like a parabola. So get something that looks like this. Do the best you can with this. Don't make it look like lines, like segments. Try to, if it doesn't look good, just erase it. I won't be able to erase mine because I'm using ink. So use a pencil so that way if it doesn't look symmetrical, you can erase it. Make sure it looks like a curve though. Make sure those are curves, not segments. Do the best you can with doing that. And so I get something that looks like this, which for the most part looks symmetrical. And so if I take that blue graph, x squared, so let's talk about x squared. So remember, x squared was this. The vertex of y equal x squared was at the origin. But I was graphing y equal x squared minus 7. So that minus 7, that subtract 7, means that you're going to take that blue graph, which had the vertex at the origin, and every point on the blue graph, you're going to move it down 7 units. 1, 2, 3, 4, 5, 6, 7. And the blue and the red should overlap. Okay, so there's the graph of y equal x squared minus 7. All right, now let's talk about this next. Let's talk about what happens if I want to graph something like number 5, and let's say it was y equal, in parentheses this time, x plus, let's say was plus 4 squared. Something like this, x plus 4 squared. All right, now, you see how in the previous problem they all look like this, the previous 3 problems, x squared minus 7, x squared plus 4, x squared minus 3, things like that? So the number was on the outside of the x squared. So you had x squared, and then you were either adding or subtracting a number. So in that case, that was where you were either moving the blue graph up, x squared up, or you're moving x squared down. That's what was happening. Now what I want you to notice is that the way this looks is not the same as this. So there's a difference between that and this. There's a difference between those two. So it helps if you look at the structure of your expression, of your function, how it's written. Here, x plus 4 is in parentheses and that's being squared. Here, x is being squared, but then you're adding 4. Okay? There it's different. So here, that's a shifting up or down. So in this case it would be up. You're shifting x squared up. So if this was x squared plus 4, you would shift it up 4 units. You would shift the graph of x squared up 4 units. If this was x squared minus 4, you would shift it down 4 units. Let's talk about this though. Let's see what happens if I have something that looks like this where what's being squared is not x squared, but what's being squared is x plus 4. So let's look at that. All right, so the way I'm going to do this is I'm going to use the t-table again. But you're going to notice, you will notice that I will not be using the same values of x that it did here. So remember, in all these problems that we've done, when you're shifting up or down, you can use 0, 1, -1, 2, -2, 3, -3. You can use those. And all these points here will be to the right or the left of the vertex. This was the vertex right here. So you'll notice that when I do this, I'm gonna plot the vertex first. You're not gonna know where it comes from, but then we're gonna have a discussion. The vertex for this happens to be when x is -4. When x is -4, I get this. I get y equal -4 plus 4 squared. Order of operation, do what's inside the parentheses first before you square. So -4 plus 4 is 0. 0 squared is 0. So I get the point 0, -4, 0. That happens to be the vertex. So I'm going to plot the vertex. So the vertex is -4, 0. So that's here. That's the vertex. -4, 0. You're going to pick 2 points to the right, 2 points to the left. Okay? Now, we're going to have a discussion in a little while how to find the vertex. How to find the vertex when it doesn't look like this, but instead looks like this. How to find the vertex. But I'm just telling you this is the vertex. So that's the vertex. Then what you do next, what you're going to do next is you're going to pick 2 points to the right, 2 points to the left. Okay? So here, the vertex, if you look at the vertex, my x value is -4. So pick 2 x's to the right and then 2 x values to the left. All right, so in other words, when you do the t-table, you found this one. So pick 2 more x values that are to the right, 2 x values to the left. So example, if you want to say -2, so you go, see how it went 2 units to the right, then go 2 units to the left. So make it look symmetrical. So this would be -4. So let's choose -4. Let's do 3 units. 1, 2, 3. So that's -1. Now you could use 0. You can use 0 if you want to. So watch. 1, 2, 3, 4. So that's 0. and then 1, 2, 3, 4, that's negative 8. By doing that, you're going to make sure that what you see will be symmetrical. All right, so when x is negative 2, notice what happens. I get y equals negative 2 plus 4 squared. Negative 2 plus 4 is 2. 2 squared is 4. So you get negative 2, 4. When x is negative 4, oops, I already have negative 4. I'm sorry, I did not mean to put that negative 4. That was, so negative 2, that was negative 6. I'm sorry, that was negative 6. Remember, I went 2 units to the right, then 2 units to the left. That's negative 6. So x is negative 6. I get y equal negative 6 plus 4 squared. Negative 6 plus 4 is negative 2. Negative 2 squared is 4. So you see how I got these y values to be the same? Kind of the same idea as before. Negative 3, 9, 9. Okay. When x is 0, I get y equal 0 plus 4 squared, which is 4 squared, which is 16. When x is negative 8, I get y equals negative 8 plus 4 squared. Negative 8 plus 4 is a negative 4. Negative 4 squared is still 16, not negative 16, because remember that means negative 4 times a negative 4. Negative times a negative is a positive, so positive 16. And notice when I plot those points, I get this. I get negative 2, remember I'm plotting these points, negative 2, 4, negative 2, 4, which is here, negative 6, 4, which is here, 0, 16, which is here, oops, right here, and then negative 8, 16, which is here. And then I draw my parabola. Do the best you can with drawing your parabola. Make it look like a parabola. Make it look like a curve. And if I were doing this in pencil, I would erase to make it look a little bit better, because it doesn't look like a parabola in this little area. But I get something that looks like this. Again, do the best you can with making it look symmetrical. All right, so there's your parabola. And so notice though, in this case, notice that the line of symmetry, the axis of symmetry, called the axis of symmetry, is no longer the y-axis, because the y-axis, the vertex, is not on the y-axis anymore. The vertex has been shifted to the left. The vertex has been shifted to the left. So I want you to remember y equal x squared. So this was y equal x squared, remember? Right here. Y equal x squared. That's right here. So notice that for this right here, which was y equal x plus 4 squared, it has not been shifted up or down. Okay, remember the only way it can be shifted up or down is that if you have that number on the outside of x squared. So x squared plus 8, shifted 8 units up. X squared minus 8 will be shifted 8 units down. But in this case, I want you to notice something. Here's the graph of y equal x squared. To get to this red vertex, I've got to go to the left 4 units. Look, 1, 2, 3, 4, and now I get that graph. So what I want you to notice is this. To get the vertex, remember the vertex was negative 4, 0. To get the vertex, you look at that number that's on the inside of the parentheses. See how this is plus 4? You think the opposite. So instead of the x going to the vertex being positive 4, it's a negative 4. So negative 4. All right, so for example, let's look at this. So if I were to ask you, find the vertex. of each of the following. So let's say I want to ask you find the vertex of number 1. Let's suppose we had x plus 10 squared. So the vertex, or we just discuss, here was the graph of y equals x squared. To get the graph of this, I would move it to the left 4 units. So you think the opposite of what you see. So the x-coordinate of the vertex would be -4. So here, what do you think, we go back to this one, what do you think the x-coordinate of the vertex is here? Well, you see x plus 10, so you would say -10. Right here, and then to find the y value, it kind of makes sense that it's 0, because what's negative? So you say y equal -10 plus 10 squared. So that's 0 squared, which is 0. So the vertex is -10, 0. Here, what do you think the vertex is? X minus 5 squared. So we're going to think the opposite. So the vertex would be not -5. The x-coordinate is not -5. The x-coordinate is a +5. And so when you find your y-coordinate, you're going to say y equal 5 minus 5 squared, which is 0 squared, which is 0. So your vertex is 5, 0. So that's how you find your vertex. So if it's x plus a number squared or x minus a number squared, the graph is shifted x squared. X squared is either shifted to the right or to the left. That's what's happening. You're either shifting it to the right or the left. Okay? So let's look at this. Suppose we had this instead. Suppose I wanted to graph y equal x minus 2 squared. X minus 2 squared. So just like we're using a t-table, I want to find the vertex. So you know the x-coordinate of the vertex. So what do you think the x-coordinate of the vertex is? The x-coordinate of the vertex is 2. Not -2, it's 2. So once you find the x-coordinate of your vertex, your y-coordinate is easy to find. You're going to say y equal, x is 2, so you can say 2 minus 2 squared, so that's 0 squared, which is 0. So my vertex is 0, 0. Once you find your vertex, then you pick you plot 2 points to the right, 2 points to the left. Once you find your vertex, so in this case my vertex is 2, 0, so you plot that point, 2, 0, and you pick 2, right here, 2, 0, and you pick 2 points to the right, 2 points to the left, and you're done. So give me an x value to the right of x equal 2, so let's say 3. You could say 4 if you want to, does not matter. You could say 5 as long as it's within this grid area that these points will fall into. So if x is 3, let's say, if x is 3, I get y equal 3 minus 2 squared. 3 minus 2 squared is 1, 1 squared is 1. So I get the point 3, 1. So look, 3, 1. And you remember the axis of symmetry, use the word axis of symmetry. The axis of symmetry goes to the vertex. Goes to the vertex. The axis of symmetry is a line, that imaginary line that goes to the vertex. So if you went 1 unit this way, then you go 1 unit that way. All right, so see how I went 2 plus 1 is 3 to get that x value? Then go this way, 1 unit. So let's say 1. If x is 1, that's going to guarantee that these y values can be the same. So from the x equal 2, to get the other x value, you go 1 unit, you get 3, go 1 unit, you get 1. That's going to guarantee that these two y values can be the same because you're using the idea of symmetry. Using the idea of symmetry. And you're going to see this. Y equal 1 minus 2 squared. 1 minus 2 is a -1. -1 squared is a +1. See, the y values are the same. So you plot the point -1, 1. Let's say you went, see where this is a vertex. So let's say you let x be 5 instead. Instead of 4, let's just say 5. So I went 1, 2, 3. So I went 3 units. I went 3 units to the right of the vertex. So x is 5. So when x is 5, notice what happens. I get y equal, wherever you see the value x, I plug in 5. So I get y equal 5 minus 2 squared, which is 3. 5 minus 3 is 3, so it's 3 squared, which is 9, to get the point 5,9. So I plot the point 5,9 right here. Looks like this, 5,9. If I use the idea of symmetry, the idea of distances, the axis of symmetry, so this distance will be the same as that distance. But remember what we did. So I went, to get 5, I went, remember the vertex is here, so I went 1, 2, 3 units to the right, so let's go 3 units to the left. 1, 2, 3 says be negative 1. So let's x be negative 1. That's going to guarantee that these two y values are the same. But verify, don't automatically put it down because you could have made a mistake. So y equal negative 1 minus 2 squared. Remember, negative 1 and a negative 2 is a negative 3. And a negative 3 times itself is a positive 9. And you got it. Negative 1, 9. So there's the point, negative 1, 9. And then again, use the idea of symmetry. Make it look symmetrical. And you have your graph. Just make it look symmetrical. All right. And so remember, this was the graph of x squared right here. This is the graph of x squared, the blue. And to get the red graph, I went to the right 2 units. 1, 2. So remember this right here was a graph of y equal x minus 2 squared. So whenever it's x plus a number or x minus a number inside the parentheses that being squared, then that's a horizontal shift. So either you're shifting to the right or you're shifting to the left. That's a horizontal shift. If the number was on the outside, just like we did earlier, then those are vertical shifts. So either you move the graph of x squared up or you move the graph of x squared down. So notice the differences between how the quadratic function is written. Let's do one more. Let's suppose we had y equal x plus 5 squared. X plus 5 squared. Let's do a t-table, but I want you to find the vertex first. Find the vertex first. So the vertex, the x-coordinate, what do you think the x-coordinate is? So the x, remember this is a horizontal shift because the plus 5 is not on the outside, the plus 5 is on the inside of the parentheses that's being squared. So think the opposite. So the x-coordinate is going to be a negative 5. So to find the y-coordinate, you just say this. You plug in negative 5 for x. So you can get negative 5 plus 5 squared. Negative 5 plus 5 is 0. 0 squared is 0. So you get the point negative 5, 0. Once you have the vertex, then the rest is easy. You just pick 2 points to the right, 2 points to the left. It helps if you can use the idea of symmetry. Think symmetry in plotting those points to the right and to the left. Make it look symmetrical. Is going to help with the symmetry part of it. So here's negative 5, 0 right here. That's negative 5, 0. That's the vertex of the problem I'm about to graph. So then we're going to pick 2 points to the right, 2 points to the left. 2 x values to the right, 2 x values to the left. Okay? So if I, let's say just go, there's negative 5, so let's say I go to negative 4. So I went 1 unit this way. All right, that's fine. You can do that. So if x is negative 4, x is negative 4, I get y equal negative 4 plus 5 squared. Negative 4 plus 5 is 1. 1 squared is 1. So use the idea of symmetry. Remember to use the idea of symmetry. Since I went, and if I plot that point, I get negative 4, 1 right here. Since I went to the right 1 unit, let's go to the left 1 unit. So that'll be negative 6. So if x is negative 6, notice that these y values can be the same. When I do that, then I'm going to get y equal negative 6 plus 5 squared. Negative 6 plus 5 is a negative 1. Negative 1 times itself is a positive 1. And so you're using, like what you're doing, you are using the idea of symmetry. So you see the vertex, so the axis of symmetry, 1 unit this way, 1 unit that way. I need one more. So let's say I go to, let's see if I can use this. All right, that'll be fine. Let's go 3 units this way instead. You can go 2, you can go one more, and that will be fine. Like -3. I want to use -2. So if x is -2, that is 3 units to the right. So -2, x is -2. So when x is -2, I got to find the y value. So when x is -2, I get y equal -2 plus 5 squared. -2 plus 5 is 3. 3 squared is 9. So I get the point -2, 9. Now I want to use the idea of symmetry. I want this to be a 9 also, so I got to make sure I use the right x value. So notice when I plot the point -2, 9, this is what I get. When I plot the point -2, 9, I get this right here. But remember, to get that, I went 1, 2, 3. I went 3 units to the right, and I'm going to go 3 units to the left of the vertex. 1, 2, 3. So I'm going to use -8 now. So -8, if x is -8, that's going to guarantee that my y value is going to be 9. And so let's check it. Y equal -8 plus 5 squared. -8 plus 5 is a -3. In parentheses, -3 times itself is a +9. So you get +9. So use the idea of symmetry. It does help. So -8, 9 is here. And so notice that the axis symmetry goes to the origin. So if you think of this imaginary line, goes to the origin, and these points are symmetrical about the axis symmetry. So do the best you can with drawing the parabola. Make sure it looks like a parabola. Make sure it looks like a parabola. Make sure these are curves, just like this, something like that. Make it look symmetrical. Make it look symmetrical. Okay, so there's the graph. This is the graph of y equal x plus 5 squared. So if I look at the blue graph again, I keep saying the blue graph, you know I'm talking about y equal x squared. So if I look at y equal x squared, which was here, then basically at the red, I shifted this horizontally. Remember, this is horizontal, right and left is horizontal, up and down is vertical. So I shifted to the left, horizontally to the left, 1, 2, 3, 4, 5. And there's the graph of, see how these two graphs overlap? They're supposed to overlap. Okay? All right, so what we've done at this point was we talked about nonlinear graphs and variations of x squared. Okay, so when we talked about x squared and variations of x squared, we saw that we had graphs that were shifted to the right, were shifted to the left, were shifted up, were shifted down. Okay, and the point from all of this is for you to find the vertex first. Find the vertex, then you pick 2 points to the right, 2 points to the left, and you're done. Try to make it look symmetrical with respect to the points that you choose. In other words, when you do the t-table, look at your y values. You want these to be the same. You want these to be the same. So notice all of these, and all of these that I've done, that's the case I chose. 4, 4, 16, 16. So we use the idea of symmetry to help us with the graphs. Okay? All right, so that's going to be the end of this lesson.